Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, hello everyone. Today we're gonna discuss another questions. Yeah, this is not a TB class question. Yeah. So this is my school final school exams questions. Yeah. So these questions is regarding derivatives for particular uh derivative for trigonometric function. This is the applications. Yeah. Finding the minimum of a functions, but this is in an applications form, applications problems form, right? So you are not given the question, you're not given the functions. You have to search by yourselves what is the functions, and then you have to do some optimizations using the derivatives. Yeah. Okay. Let's just get started with the questions. Okay, we are given a figure of a house, and then there's a ladder there. Yeah, there's a ladder there. Yeah, this is the ladder. Uh, this is the ladder. Yeah, and this is the house, right? So the house is connected via a ladder, and then we know that the length of this, yeah, the length of this part, yeah, this is the connect. This is the 2 meters. Yeah. So this is what is it? What is that called? Yeah, exactly. This is the column to or the structure to hold the stairs. Yeah, this is the structure to hold the stairs. The length is 2 meter, and then we know that this distance is also 2 meters. Yeah, and then the question state, yeah, which what is the minimum length of this ladder? So this is the ladder. We have to find the minimum length of the ladder. Yeah, using the information given by the questions. So we know, yeah, if we want to sketch it out again separately, this would be the ladder, right? And then we have this structure, the column, yeah, that holds the stairs, and then it has length of 2 meters, and then this distance also has 2 meter. Yeah, okay. And then okay, we are being asked with the minimum value of the length of the ladder. Now of course, the first task that we should do, the first thing that we need to solve is what is the function that describe the length of this ladder, because we have to find the minimum length of the ladder. So if we want to find it, we have to know the function first, right? So these are the lengths, right? These are the lengths. So let's call it L, right? So for finding L, yeah. So for finding L, I could do these separations. Let's just call this area, let's just call this length to be L1, and then this part, this part is L2. Okay, okay. And then I assume that we have this angle theta here, right? So I assume that the length of the ladder would be depend on the angle of this ladder, right? Because as the theta growing, it would affect the length of the ladder, the length of the ladder too. So theta must to be considered in this equation. So you might have get the general idea of the function. So the function would be depend on theta, right? So we have to find the L1. So we know that the total length, the L, would be L1 plus L2. Now, because the length is depend on theta, then we have to find L1 and L2 and in theta. So L is the function of theta, right? So now let's just let us find what is L1. So L1, so you take a look on this take a look on this triangle. So these triangles. Now this triangle, it has the length of 2 meters, and the angle is theta, right? Now, and this is L1. So now to describe L1, we could do some simple trigonometric ratio. We can use sine theta based on this triangle. What is sine theta? It would be the opposites to and the hypotenuse L1. So L1 would be 2 over sine theta, or 1 over sine theta would be equal to 2 cosecant theta, right? So this would be L1. And then what about the L2? Yeah, what about the L2? Okay, L2, take a look on this triangle. Which triangle? Okay, this would be the hard part of the questions. I have done this question separately, yeah, individually, and this is the most unexpected part of these questions. We know that this angle is theta. Now, we could project this angle theta, yeah. I could do some helping line, I would say, auxiliary lines, yeah. I'll make some auxiliary line here, yeah. So uh this would be the actual auxiliary lines, yeah, right? And then the angle here that being formed with this would be also equal to theta. Yeah, right? Did you get the idea of why the angle is theta? So because it has some I would say symmetry, yeah, congruent. It has some congruence with this big triangle. Then the angle here would be the same as the angle here, right? So another analogy that you can use, that this angle theta is formed by these lines, right? This line, which is, I would say, in x-axis, yeah, right? This is an just pretend this is an x-axis. This would be also the x-axis, right? And the angle theta here is formed between the line in the x-axis and this line, these straight lines, right? The L1. Now, for the L2, the case is also the same. So this is the auxiliary lines that I use, that I made earlier, is just the same as the projections of the uh, x-axis lines. And L2, so projections of L1, it's the part of L1 too. Now, since it was two diff two same thing forms, so basically the angle would be just the same too. Would be equal. It would be equal. So the angle would be theta too. Okay. So you get the analogies here. Yeah, you can think it like that. Now, since this was theta, yeah, this theta and this L2, then this and these lines, yeah, the auxiliary lines that I made earlier, this would be equal, the length of it would be equal to 2 meters, because basically I'm just projecting these lines to the upper sides, right? So it would be at 2 meters too. Then the ratio that we can use is the cosine theta is the adjacent 2 over hypotenuse L2. Then L2 would be 2 over cosine of theta, which is equal to 2 secant theta. Then L1 here, we could do some simplifications. We could insert the value L1 plus L2, which is L1 is 2 cosecant of theta plus 2 secant of theta. Now, after we already have the functions uh for the questions, yeah, for the problems, it just a straight answers. It would be easy. Yeah, it would be easy after this. Yeah, because There's no need to worry about anything else. Basically, if you already have the functions, you just do some derivative, right? So you know that the functions, the conditions that the method that we have to use to get the minimum or the maximum value of a functions would be, we just derived it to the respect of the variable and equal it to zero, into zero. So okay, let's just derive this L. Yeah, we just derive L prime theta. So we derived it to the respect of theta. Yeah, of course, because the variable here is theta. So 2 times cosecant of theta. What is the derivative of cosecant? This would be minus. Yeah, so minus cosecant, cosecant theta, cotangent of theta, plus 2 times the derivative of secant, which is, yeah, secant theta, tangent of theta. And we know that we have to equal, the left hand side would have to be equal to 0 to find the value where the theta is maximum or minimum. Now this would be minus 2 cosecant of theta, cotangent of theta, plus 2 secant of theta, tangent theta. Now we could do some simplifications here. This would be cosecant of theta, cotangent of theta equal to secant of theta, tangent theta. Now, uh, we could expand this. We could do some simplification here. We know that cosecant is 1 over sine, cotangent is 1 over tan, secant is 1 over cosines, and tan is just tan. Now we could do some simplifications here where 1 over tan square theta is equal to tan, the tan of theta. Then the tan to the power of 3 tan cube theta is equal to 1. Then the tan of theta is equal to 1. Now, since the value of the theta would be on the range only for the when the okay, we have to agree, yeah, we have to agree that the angle for the theta e here, the only allowed intervals for the theta, yeah, intuitively we could uh, determine it by the theta have to be in the interval of 0 to 90 degree, right? Because we know that if the angle is more than 90 degree, the ladder would be just like this, and this is the theta, right? And this would be inefficient, yeah, since we could because this would be inefficient since we could just calculate the angle for this ladder just by using this angle. Let's just call it phi. Rather than using the theta, it would be more efficient to just use phi, which phi itself, the range of the phi would be just in the interval of 0 to 90 degrees. So we have to agree that the angle of the theta would have to be in this interval 0 to 90 degree. Now, of course, this tangent of theta is equal to 1. So, this we could simply we could deduct that the theta have to be 45 degree, because the only theta that satisfy these equations is only 45 degree. So the angle have to be 45 degree in order to minimize the length. to minimize the length of the ladder. Now we could insert it to the initial functions. Yeah, we know that the function is L in the function of theta is 2 over sine theta. So I expand this cosecant to 1 over sines because it would be easier to find the value for sine and cosine rather than finding the value of cosecant and secant. So this would be 2 over cosine of theta. So the L theta would be 2 over the theta would be 45 degree, right? Plus 2 over cosine of 45 degree. We know that sine of 45 degree is a half times the root of 2, and also the cosine would have the same value since cosine of 45 degree and sine 45 degree has the same value. So this would be a half times the root of 2. And we could do some simplification here for over 1 over a half root of 2. And this would be 4 root 2. And this is the minimum length, the minimum length. So the value of it would be 4 4 times the root of 2. So your answer will be 4 root 2 meter. I think that's all for these questions. I know these questions is kind of a hard questions, yes, since it involves a lot of concepts and rules, yeah, because cosecant of a theta, you might won't be remembered what is the derivative of it. Yeah, since we're not using it a lot. Yeah, the cosecant and secant, but yeah, you have to remember it for the sake of completing these questions. Yeah, I think the part that makes it difficult is finding the functions. Yeah, finding the functions for this particular applications problem. Yeah, because uh you have to notice, yeah, first of all, you have to notice that uh there is an angle theta. So the lengths you have to discover, yeah, the part that made this hard, yeah, that make it difficult is that you have to notice that the value of the length of the ladder would depends on the angle of the ladder. Yeah. So for people who are not regularly doing exercise and problems, you might not noticing it. Yeah. And then the second one, yeah, you have to remember the rules for the derivative. Yeah. Not well known derivative. Yeah, like cosecant and secant. And then you have to use the trigonometric ratios to determine the functions. Yeah. So yeah, it's kind of difficult, but I suppose that if you're exercise enough, you're facing where you have faced various type of questions. I think these questions would be so easy for you. I think that's my thought on these questions. Okay, it appears to be hard for people who doesn't do a lot of exercise, but if you're exercise enough, you would be familiar with this kind of questions. I think that's all. Yeah. Okay. I think thank you for listening to my explanations. I hope that it will help you in studying. Yeah. Keep practicing and keep watching my video. Please subscribe my video. Yeah, okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh.